Hello students, welcome to Lucky Learning. Here in this video, I am going to discuss one of the important concept called direct memory access. We call DMA in short. Suppose we have a magnetic disk, okay, magnetic disk that has some data, and this data, if it is to be transferred to main memory, we don't have any direct connection between magnetic disk and main memory. Now magnetic disk called IO device. Now to transfer the data between magnetic disk and main memory, between them we have a CPU, central processing unit. Now data is to be transferred from this IO device to CPU through IO interface. Through IO interface, it is to be transferred between magnetic disk to IO interface to CPU. And then once it reaches to CPU, then it has to go from CPU to main memory or main memory to CPU. It means to transfer the data between main memory and IO devices, we have an intervention of CPU. Now, here in this direct memory access, we have to relieve the intervention of CPU. Means without the intervention of CPU, the transfer of information between the main memory and magnetic disk, or we call IO devices, should happen directly. This concept is called direct memory access. Now, the transfer of data between the memory and external devices without involving the microprocessor, means CPU, improves the speed of transfer. This transfer technique is called direct memory access. Now here you understand. Now CPU is having address bus, data bus, read write control signals, and BR and BG. We call A bus is called address bus, D bus is called data bus, it is a bidirectional, and read control signal, write control signal is sent to IO devices or memory units by sending read and write control signals from the CPU. And it also has BR, we call bus request, BG called bus grant, that is to be sent to a DMA controller. Now, whenever DMA requires the address bus, data bus, or else we can call the buses that are handled by the CPU. Now DMA controller is going to send one control signal to CPU saying that bus request. Upon seeing the bus request signal by the CPU, now CPU is going to terminate the current process and keeps this address bus, data bus, read write control signals into high impedance state. It means those are disabled, and the CPU is going to send another control signal to DMA, that is bus granted. It means CPU informs to the DMA controller stating that all the buses are relieved by the CPU. Now DMA can take control of these buses to perform a direct transfer. So once transfer is to be performed, now how transfer can be done? Transfer can be done in terms of burst. It means a continuous memory words is going to be transferred in a single burst. We can call burst transfer, or it is going to transfer one word between memory and IO devices by skipping one of the CPU cycles. Then it is called cycle stealing. Once transfer is completed, the DMA is going to disable the bus request control signal, and CPU, upon seeing that bus request signal is disabled, the CPU is disable the bus granted signal, so that all the buses are going to be taken handed by the CPU. So it means previously the all the buses and read write control signals are in the high impedance state. Now it will be taken back by the CPU. Now CPU can communicate or control take the control of address, data, and read write control signals and continue with its work. Here we understand the two control signals, that is bus request. It is used by the DMA controller to request the CPU for the buses. When this input is active, what CPU will do? Terminates the execution of the current instruction and places this address bus, data bus, read write lines in a high impedance state. What is bus grant? CPU activates the bus grant output, inform the DMA that buses are available in high impedance state. DMA, once it gets bus grant signal, it take control over the buses to conduct memory transfers without the processor intervention. Means the transfer happens without the intervention of CPU. When DMA terminates the transfer, it disables the bus request line and CPU disables the bus grant and returns to normal operation. And whenever DMA controller takes the buses from the CPU, the transfer is to be done in two ways. One is burst transfer. What is a burst transfer? A block of memory words are transferred in continuous burst. It means not one word is to be transferred, it is to transfer a block of words. And another way is called cycle stealing. This allows DMA controller to transfer one data word at a time, after which it must return control of the buses to the CPU. It means CPU is simply delaying its operation for one memory cycle to allow DMA to steal one memory cycle. When you look for DMA controller can take over the system bus and transfer data between memory and IO modules without the intervention of CPU. Whenever CPU wants to send the data, it tells the DMA controller what is the direction of the data. It means two IO devices are from IO devices, or we can call read or write. Read from memory or write to the memory. And also it has to tell the starting address of the memory block when it is to perform a burst transfer. And also it has to tell the word count, which is the number of words in the memory block is to be read, how many words it is to read. And also to specify the mode of transfer, such as read operation or write operation. And a control to start the DMA transfer. Here you look at DMA controller typical diagram. It requires to have address bus buffer, address register to hold address register to hold the starting address of the memory, and word count register to store how many words it is to be transferred, and control register will specify the direction of the transfer, whether it is read or write. And all these internal registers will communicate with internal bus. And in also we have bidirectional data bus. These bus buffers are to the CPU. DMA controller will have a control logic circuit. This control logic circuit will have DMA select to select this DMA controller, and register select will be used to select one of the four registers like address bus buffers, address registers, word count register, control register, and a read control signal received by the CPU are sent to the CPU, and a write control signal. And whenever IO devices wants to communicate with the memory, IO devices will send a DMA request to the DMA controller. Then the DMA controller will send a bus request signal to the CPU. Upon seeing the bus request from DMA controller by the CPU is going to relieve the data bus, address bus, read write control lines into the high impedance state and send one control signal called bus grant. Once DMA controller receives the bus grant, then it is going to send an acknowledgement to IO devices saying that the buses are ready to perform the data transfer. This is a typical diagram of a DMA controller. Now what DMA controller will do? Interrupt the CPU so that DMA controller will take the control of those buses to perform a transfer. Now here you observe DMA controller is used to transfer the data between the memory and IO. And the DMA controller needs the usual circuits to communicate with the CPU and IO devices. In addition to this, it needs what address register and address bus buffers. It is to store the address of the desired location in the memory, or we can call starting address from where it requires to read the words. And word count register holds the number of words to be transferred. The control register specifies the mode of transfer for read or write. The DMA communicates with IO devices through DMA request and DMA acknowledgement line. The DMA communicates with the CPU through the data bus and control lines. The read-write signals are bidirectional because that read-write control signals will be from DMA controller or to DMA controller. And when BG signal is 0, means bus grant signal is 0, the CPU can communicate with the DMA registers to the data bus. When BG is 1, it means bus is granted by the CPU. The CPU has relinquished the buses, means relieved the buses. Then the DMA can communicate directly with the memory. The DMA requests CPU to hand over control of buses to the DMA using bus request signal. The CPU grants the control of buses to DMA using bus grant signal. After placing the address bus, data bus and read-write lines into high impedance state. Now here this is a process of DMA transfer. Means whenever IO device make a request to the DMA by sending a DMA request control signal. So what DMA controller will do? Will request for buses to the CPU by sending bus request signal. Upon receiving the bus request signal, what CPU is doing? Sending a control signal called bus grant to the DMA controller, saying that all the read-write control signals and address and data lines are goes into high impedance state, means that are relieved by the CPU. And once control is taken by the DMA controller is sending an acknowledgement to IO device so that the data transfer can happen directly between IO and memory without the intervention of CPU. This is a typical process of DMA data transfer. DMA transfer, look at from IO device to memory. Here IO device sends a DMA request. DMA controller activates the bus request line. CPU responds with the bus grant line. DMAX sends acknowledgements to the IO devices. IO device puts a word in the data bus for memory write, and DMA controller write a data to the address specified by the address register, and the word count is going to be decremented to count the number of words is transferred or not. When word count register comes to 0, it is meaning that end of the transfer and CPU is interrupted to take control of the buses. And word count register, if it is not 0, DMA controller checks DMA request from the IO device. Okay. And when it comes to the IO device, CPU executes instruction to load memory address register, load word count register to know how many words to be transferred, and load the function, that is read function or write function to be performed, and issue the go command to perform a transfer. Now for each word that is transferred, DMA increments its address register so that it will go to the next instruction, and decrements its word count register so that it will count the required number of words is transferred or not. If the word count does not reach to 0, the DMA checks the request line coming from the peripheral. Means is it request is enabled or disabled. Means is it continue the DMA transfer. And if the word count register reaches a 0, the DMA stops and any further transfer and removes its bus request. This is what going to happen with DMA transfer. And hope you have understood DMA, direct memory access, how the transfer is happened between the IO and memory without the intervention of CPU. The process you might have understood. Hope you have enjoyed the video. If you like the video, please do like, share and subscribe. And don't forget to click the bell icon for the regular updates. Thank you.